Hello everyone. Let us discuss the frames of reference. There are two types of frames of reference based on Newton's law. That is the inertial frames of reference, and non-inertial frame of reference. Let us first discuss about the inertial frame of reference. An inertial frame of reference is one in which the Newton's first law of motion holds good. Every body continues to be in its state of rest or of uniform motion unless acted upon by an external unbalanced force. That is, if an object is at rest, it will remain at rest unless it is acted upon by an external unbalanced force. Suppose an object is moving with a constant velocity, it will move with a constant velocity unless it is acted upon by an external unbalanced force. So, a frame of reference that obeys Newton's first law is known as inertial frame of reference. Inertial frame of reference is also known as Galilean frame of reference because it was Galileo who first formulated the law of inertia. It is also known as non-accelerating frame of reference. Now consider a frame of reference which is moving with a constant velocity with respect to an inertial frame of reference. That is, S dash is a frame of reference and S is an inertial frame of reference. Observer in the S frame is at the origin O and the observer in the S dash frame is at the origin O dash. Now at time t equals 0, let the origin O and O dash coincide. When the measurement start, S dash frame is moving with a constant velocity v along the straight line. Let P be a point where an event occurred. So the position vector of the point P with respect to the observer O be R and the position vector with respect to the observer O dash be R dash. Then during the time interval t, since this S dash frame is moving with velocity v, we know that the distance covered by this S dash frame in the time t is velocity into time. So we have OP equals O dash plus O dash P, that is R equals Vt plus O dash is Vt plus O dash P is R prime. So R equal R dash plus Vt. So we are going to set the fact that a frame of reference that is moving with a constant velocity with respect to an inertial frame is also an inertial frame of reference. This S dash frame is a frame, this S dash is a frame which is moving with a constant velocity v with respect to the inertial frame S. We are going to prove that any frame of reference that moves with a constant velocity v with respect to the inertial frame is also an inertial frame of reference. So, for that differentiate this equation. On differentiating this equation, we have dr by dt equals dr dash by dt plus v. Again differentiating, we got d square r by dt square equals d square r prime by dt square. Since time is independent of the frame of reference, t prime equals t. So it can be written as d square r by dt square equals d square r prime by dt prime square. Okay, this means that acceleration of the object measured by an observer in the S frame, that is A, equals acceleration of the object measured by an observer in S dash frame. That is, the acceleration is invariant with respect to the reference frame. That is, if an object is at rest with respect to an observer O in the S frame, it will remain that object is at rest for an observer O dash in the S dash frame. This equation means that is acceleration is invariant means if an object is moving with a constant velocity v with respect to an observer O, that object is moving with a constant velocity for the observer O dash also. That is a frame of reference that moves with a constant velocity with respect to an inertial frame is also an inertial frame of reference. So, next we go to discuss non-inertial frame of reference. Non-inertial frame of reference means where the Newton's first and second law of motion does not hold good. That is, these are accelerated frames of reference. Non-inertial frame of reference are accelerated frames of reference. Rotating frames are examples of non-inertial frame of reference. Suppose now consider an accelerated frame of reference and the object is at rest. Even though no force acts on it, no force acts on the object, the object experiences a force due to this accelerated frame of reference. That is, the object experiences a pseudo force. For example, we consider a lift and an object is at rest in the lift and the lift is descending downwards. So, that object which is at rest in the lift experiences a pseudo force mg. These frames are known as non-inertial frame of reference. So, accelerated frames of reference are non-inertial frames of reference where the Newton's first and second law of motion does not hold good. Where in the inertial frame Newton's first law of motion holds good, and any frame of reference which moves with a constant velocity with respect to an inertial frame is also an inertial frame of reference. Thank you.